deep into anaerobic respiration. So already we know that there are two types of anaerobic respiration, lactic acid fermentation and alcoholic fermentation, correct?
Yes.
What is the organism which has the ability to respire aerobically and anaerobically?
Okay. So could you repeat the question?
Which is the organism which can respire aerobically as well as anaerobically by
Mitochondria.
alcoholic fermentation? If I ask you what is the organism which can respire aerobically and anaerobically, so obviously we can say we, because we can respire aerobically, we can respire anaerobically also, correct?
Yes.
But we are justifying now, the more clearer vision, like which organism can respire with alcoholic fermentation also.
Yeast.
Yeast. Yeast can respire aerobically as well as anaerobically, correct?
Yes.
For example, now we are going into depth of anaerobic respiration. For example, we are using yeast. This will be the topic where you can learn, you can relate this topic for the next topic also. For example, this is a test tube, okay?
Yes.
In this test tube, we have sugar. We have a sugar here, okay? All the sugar is there, correct? Moreover, we are putting in this test tube some of the yeast. Okay, this yeast is there, okay?
Yes.
Okay. Now, once we are talking about the yeast, correct? Now yeast will be producing obviously, and if we put one small balloon on top of it, okay, a balloon
Yes.
is there on top of it, okay. So now what will happen? This balloon will start to inflate. Obviously, why this balloon will inflate? Inside what we have? We have yeast plus sugar, yes?
Yes.
Now, this balloon will start to inflate. Why?
Because yeast is reacting, so it's forming carbon
Not
dioxide.
reacting. Yeast is respiring.
Respiring. Yes.
Yeast will respire using the sugars, and it will obviously, once the yeast will respire, so it will be producing carbon dioxide. So this balloon will start to inflate. Correct?
Yes. Yes.
Now, if we want to determine which type of respiration the yeast is going on, aerobic or anaerobic?
Anaerobic.
How anaerobic? So technically speaking, look, once
Yes.
this test tube was there, and after in this test tube we put the yeast plus sugar. So after that we cover it with the balloon, yes. So some of the oxygen is still there in this test tube. So yeast will be respiring, it will be using that oxygen first. Once the oxygen which was present in this test tube, it will be used up, only then the yeast will start to respire anaerobically, correct?
Yes.
Now, what is the problem? We don't know exactly how much amount of carbon dioxide is produced aerobically and how much amount of carbon dioxide is produced anaerobically. This is first problem, correct? Secondly, we don't know when the yeast is respiring aerobically and when the yeast is respiring anaerobically. This is the biggest question.
Yes.
Correct? Now,
Yeah.
the point here is there are different kind of processes. So, for example, there are different, we will be doing this thing in the core practicals. We will learn this thing in the core practicals, how we can justify that yeast is respiring anaerobically or aerobically. I think I showed you this thing before. It
No,
was
sir.
you or someone else. No, the other student. No, not you. Okay. We will be discussing this thing in the next video where I will show you how we can confirm the yeast is respiring aerobically or anaerobically. Okay,
Yes.
so we have to differentiate between these two, that now yeast is respiring aerobically and now the yeast has started to respire anaerobically, and the carbon dioxide which is produced, it is the product of aerobic respiration or anaerobic respiration of yeast. So the problem, major problem that was linked with this thing, now you understood, yes, this
Yeah.
balloon getting carbon dioxide with the aerobic respiration or anaerobic respiration. So still we are not sure of, correct?
Yes.
Because in both ways, yeast is producing carbon dioxide, so we cannot specify, correct? So this question, we move to the next topic, okay? Next video. This first depth question for anaerobic respiration, alcoholic fermentation, correct?
Yes.
Okay, now next in depth, if we go for anaerobic respiration, that is actually the point which we are raising about alcoholic fermentation. I told you in alcoholic fermentation, what are the points in the alcoholic fermentation? There is a term that is known as, there is a term that is known as oxygen depth. Please make note of this. This is required, okay? Oxygen
Yeah.
depth. Now, since I told you the lactic acid fermentation, acid has the ability to convert back into glucose. It can be converted back into glucose, correct? With the help of oxygen,
Yes.
correct? Now, once one athlete is running and that athlete is a sprint runner, correct? Now, please, I'm formulating a question and please make note of this question, okay? Athlete is running and that is a sprint run, like 200-meter race. So he
Okay.
has to produce a lot of energy at very short period of time. Maybe he has to produce 5,000 joules of energy in 1 minute or less than 1 minute, depending upon his speed, correct? So
Yeah.
now, so once obviously that fellow will be using, it will be sprinting, so he will be making lactic acid, correct?
Yes.
So first of all, to meet up the requirements of that, his breathing rate and heartbeat will be higher. Agree?
Yes.
You can justify this thing, correct? Why the breathing rate and heartbeat will be higher? Why?
So the muscles require energy.
More energy. So muscles need more supply of glucose and more supply of oxygen. So that is why more times the heart pumps the blood to supply more oxygen and more glucose to the muscles, correct? So that is why heartbeat and the breathing rate is there, yes?
Oh, yes.
Okay, no problem. But at once the breathing rate and heartbeat was higher. Why? Because energy requirement was higher. So body was pumping, heart was pumping more blood into the muscles, correct? Okay, agreed. To supply more oxygen and glucose, correct?
Yes.
Once the sprinter finishes his race, yeah, target, endpoint, yes,
Yeah.
still his heartbeat and breathing rate is higher. Why? Normally, in normal circumstances, the heartbeat is, but the breathing rate is 20 beats per minute, BPM. Now,
Yes.
this is actually, this is directly linked to this part. Make note of this. This is directly deep into anaerobic respiration, and we are not discussing what? Lactic acid fermentation, okay? Lactic acid fermentation. The thing that we are discussing now, these are the exam questions,
Okay.
okay?
Yes.
Now, the point is, why? Okay, once he was running, he required more energy, so his BPM, breathing per minute, or beat per minute, both way we can use it, okay? BPM we can use for the both breathing and beat per minute. Normally BPM we use for the heartbeat,
Yes.
isn't it? Okay,
Yes.
in both cases, BPM is higher. Okay, acceptable. But once the athlete stops, still there is high BPM. Why? Because now the energy requirement is very less because it's normal. In normal circumstances, this is not, it is required 20 beats per minute, correct?
Yes.
In normal circumstances, once a person was, what to say, he was running, so maybe this BPM reached to, the breathing per minute reached to 30. Okay,
Yes.
okay. But once he stops, it should come back again to this. Yes, immediately, because energy requirements are no more. Why
Yes.
still there is 10 times more heartbeat than the normal? For what purpose?
To so when he was running, there was no sufficient oxygen.
No,
So
no, no.
lactic acid was produced,
Okay,
and
very
now
good. Okay, correct.
yes, and now the muscles. So now the lactic acid will be converted back into glucose by oxygen, by the help of oxygen.
Very, very good. That is what. That is why the term that I have introduced, that is known as oxygen debt. Body is in debt of oxygen. Why that debt of oxygen is there? Because during this course, during this sprint, the body has produced lactic acid to get energy, correct?
Yes.
That extra energy which was produced, it produced lactic acid. Lactic acid is unwanted substance. It is
Yes.
harmful substance for the muscles. Yes,
Yes.
because lactic acid influences the muscle efficiency. Correct. So that is what. Now, after even ending up with the race, still there is the difference. 10 times more breathing rate is there. Yes.
Yes.
So why the still body is inhaling more oxygen, okay, maybe 10 molecules of more oxygen. Why? Because these 10 molecules of oxygen, they will be used to convert lactic acid back into glucose. Excellent. That is why we are calling it oxygen debt. After that, it will come to 9. From 9, it will come to 8. From 8, it will come to 7. And ultimately, it will come to again to
20.
20. It will get normal. It will take time, but still the breathing rate is extra from the normal. Why? It is known as oxygen debt.
Yes.
This oxygen debt, there is another term that is used that is known as post exercise excessive post exercise oxygen consumption.
Yes.
E EPOC. EPOC. Excess post exercise oxygen consumption. This is the same thing which is oxygen debt. Same thing. Why the oxygen consumption is excess even after the exercise? So this extra oxygen which is body is inhaling, that is to convert the lactic acid back into glucose to bring the body back into the normal. So the energy which was produced to convert glucose into lactic acid, that energy, that oxygen will be paid back
Yes.
to get back the same amount of glucose. Correct?
Yes.
EPOC, excess post exercise oxygen consumption. So EPOC is actually oxygen debt. So that is why you can name it now. Why? So these are the more depth questions related to lactic acid fermentation.
Yes.
Any problem?
No.
So we are, you know what, we are done with this topic also.
Oh wow. Yes.
Okay, we are done with this topic also. So